What is up? It's your boy the Canologist. We're going to be doing Contains Duplicate 2, the second version. It's like Grand Theft Auto for containing duplicates, except it's a newer version of that shit. Okay, so let's see. Given an integer array nums, okay, cool, an integer k, return true if there are two distinct indices I and j such that nums I equals nums j, and absolute I minus j is less than or equal to k. Okay. Nums I, nums j are the same, so they're equal to k. True. 1. Well, wouldn't that always be 0? Or is it turned false? So for example, you got 1 minus 1, 2 minus 2, 3 minus 3, absolute ij, k is from 0 to 10 minus 5, okay. Nums I equals nums j. And absolute I minus j, oh, the actual index, I minus j is equal to k. Okay, so it's saying nums I, nums j, so if we find the duplicates, then we got to compare indices of that duplicate. Can you add multiple items to an entry? That's what I'm thinking. Okay. So basically I have to find duplicates and I have to reference okay, so this is what I'm going to do. How many minutes have gone by? 5 minutes. Okay, so I have about 15 minutes to solve this before I go to ChatGPT. So this is just to get me to work faster and become more efficient at solving, and if not, I learn a lesson on how to get more efficient. Okay, so this is what I'm thinking. 2 dictionaries. One to check if there's duplicates, and then one to check indexes. Actually, no, that doesn't work. Oh, okay. I might actually be smarter than I think I am. We can do a dictionary of key value pairs where the key is the number and the value is the array. An array containing the index. So what I could do is stores equals dictionary. Then I can go for I num in nums. Then I want to go fucking, what is this shit? Okay. Then I want to go if num not in stores. If the number's not in stores, create the elements. So stores num equals 0. Second thing is stores. Oh, yeah, stores num equals 0. No. Stores num equals empty array. Stores num equals empty array. And then oh, but this doesn't get the index, so this has to go. Oh wait, let me go with Z. I need indexes, so 0 to len nums. So I go 0 for I. Nums at the index, so the value of the array is not in stores. Add stores nums I. create an array, then I want to go let's see. So there could be multiple instances of numzi equals numj, right, where there's duplicates, but we need to find one that's less than or equal to k. So num stores num dot append I. Now we just add indexes to it. Max minus min has the greatest difference. So we don't want something with a greater difference. We want something with the least difference. So what I'm just going to do is look at the first two elements of whatever's in there. So if there's 5 elements, you don't want something with a greater difference because that's going to have a greater result compared to k. You want the ones with the least. So what I'm going to do is append all this. How much fucking time do I have left? 12 minutes. Okay, so I have 8 minutes left to solve this. Right now I go through all the elements, and then every time I see an element, if it doesn't exist in the dictionary that I created, I'm going to create an array for it in that dictionary and then add the index for it. Because I don't care about the actual element itself. Because now that I know the elements exist, all I have to do is just compare whether it's greater or less than. So basically, at this point, I gotta go through each element of the array, so key. For key val in stores. So first I'm gonna say if length of stores is 0, there's no duplicates. Actually, wait, no, that's not true. I'll just return false in any case. It's gonna go through the whole stores array anyways, stores items. Since it's going in terms of index, the lowest is already gonna be first. It's adding them as it goes. So you can only go higher on the scale. So I only want to compare the 2 indexes. So basically I'm looking at this. Basically if ABS absolute value of val, because val is the array, so val 0, first element minus the second element, because those are the 2 smallest elements of whatever could exist in a duplicate. So then I'm going to go if len val. So if length of the array is less than 2, Continue. That way we skip all the items that we don't need. Absolute value of val1, val0 minus val1, less than or equal to k. Return true, and then return false otherwise. That should be good. Let's run it. For key valid storage item. Okay, put a colon. Stores num. Oh, there's no num, so it stores num's I dot append I. False expected true. So what am I doing wrong here? If the length of the array is less than 2, we continue because there's no duplicate, right? So we only care about the duplicates in this stored dictionary. The other thing is, if absolute value of array position at 0, so if there is a duplicate, take the first two elements, subtract them, get the absolute value of the first two elements. Or technically, it could be 3 minus 4. How do I find the absolute difference that's the least? This is the issue. It's like, okay, because technically if I had this minus this, that's a lesser gap than this minus this, or this minus the first element. Because this is only one difference. That's why it's saying absolute value of I minus j. This is where I'm getting stuck. What is the... I'm at 70 minutes. Fuck. Okay. But I got close. This is my logic, which is pretty good. Up until this point here, this one line. Okay, let's look up run two nested loops, find the closest element. So 10, 5, 16, 11. Find the closest element in every array. Find closest two items in an array. In an NP array, arrange. Find the two closest values in one array. Smaller and higher. Oh my gosh, this is so long. How much time do I got? I'm at 19:30. Okay. It's taking too long. Let's just go to ChatGPT. This is what I need to fix, but the logic here is pretty much sound. Okay, let's see what they got here. Chat GPT instructions. Because I just want to figure out as fast as possible what the item is. I need to get rid of my roadblocks the same way. so I could become a more efficient solver. My solution. I know falters near Please advise on how to fix. You can optimize your approach by using a dictionary to track the most recent index of each number. Your kernel keeps track of all, but it only checks the first two indices. Instead, you can maintain a single dictionary where each key is a number from the array and its value is the most recent index where this appeared. Okay. Oh, so you just do it live. Okay. So store the last element of the index. So for I in range. So if num's I in stores, if the number is in stores, I minus stores, check if the difference between the current index and the last index. Oh, if I is in stores, you check it. If it's not in stores, you just add it. So it's pretty much the opposite approach to what I did. If I did if it's not in stores, add it. It's saying if it is in stores, check it. Okay, update the most recent index, the current number. So stores nums I equals I. Okay. How do I fix the method I had? Closest indices. So stores items len val 2. Val.sort. Oh, len val minus 1, because you have to take two elements. So basically iterates through every single element. Sort the indices and check adjacent indices. So you're running a double for loop is what it's saying in each one. Whereas in this solution, you could just do it through one array. So we could do it that way. So the way that I had it originally, I have to find the element where it's, so basically this is what it does. It goes val.sort, it sorts the array. Then you want to go for j in range val. So it's going to be len val minus 1, but we also have to look at 2 at the same time. So it's going to be len minus 1. It's already minus 1, so it's going to be minus 2 because you're looking at 2 elements, and 1 element's going to go to the last one. It's going to be val at, all you got to do is just shift this whole thing, val at j minus val at j plus 1. And if any of these elements in this is less than or equal to k, return true. That's what it does here. That's what I'm going to do here. So val j plus 1 minus val plus j. Val j plus 1. It's absolute value, so it doesn't fucking matter. Let's try that. Boom, submit. And boom, it works. Beats 6.45%. The reason why it doesn't beat a lot of solutions here is because it doesn't, it has an O of n squared time complexity here and an O of n space complexity. So what I want to do next is we could also kind of solve it. We could dissect the way ChatGPT solved it up here to create one dictionary. So basically the way I did first is I create a dictionary of all the entries and I create an array. So it saves all the indexes, right? And then I'm basically saying for each item in my dictionary, I want to check if those arrays are greater than the length of 2. So that way, if it's not greater than the length of 2, it's not a duplicate, so we don't care. If it is, then sort it. And then we check each value in that array to see if any of the differences is equal to less than or equal to k. And if so, return true, else return false. The way they do it here is instead of storing all the elements like I was, they just store the most recent one, right? So they're already doing the check live. So that's just an O of n check and an O of n space. So what they do here is they go from I to range len of numbers, so the length of numbers. Then they go numbers I in stores. If the number is in stores, they do the check. So I, the current value in stores already, minus stores nums I. Well, this should be absolute value of minus stores nums I is less than or equal to k, right? And if so, return true, right? If this is already in there. If it's not in there, you have to add it. So this adds the most recent one. So if it doesn't exist, add it. And if we find another occurrence of it, if nums I in stores, we check it against k. That's what it's doing here. This is actually way more efficient than the one I did, but I'm just giving you guys options here. So if you like the video, please give it a thumbs up. Add your comments to the comment section below and subscribe to the channel. Knologist out.